Is everybody ready for the best accessibility I/O ever? Woo! Right on, right on. My name is Brian Kemler. I'm a PM on Android accessibility. Our goal is to ensure that everyone can use our products no matter what their ability. Specifically, we design and build Accessibility Suite, Sound Amplifier, Live Transcribe, and now Live Caption. We've invested heavily in the last year to make audio on Android much more accessible, so we'll be focusing a lot on that today. Here with me today are Melissa, Lauren, and Kelly, our passionate team of researchers, programmers, and engineers. Today I'm going to share my perspective on accessibility's mission and why it matters. I'll discuss new products for the deaf and hard of hearing. Melissa will show you how we'll use structured research to inform our most important product-making decisions. Lastly, Kelly and Lauren are going to talk about new products for users with physical disabilities, reduced dexterity, low vision, and blindness. So now let's talk about our mission. Accessibility's mission is integral to Google's. So integral, it's in the mission statement itself, to make the world's information universally accessible and useful. Let's unpack that a little bit. Universally accessible means everyone can use Android. We don't expect users to adapt to our products. Rather, we adapt our products to our users because we think of accessibility as a human right. If there are barriers for anyone, we have more work to do. And it's with this mantra that we design, build, and apply Google magic to make both our products and the real world around us more accessible and more useful for more users in more situations. The world's information means it's not just about making what's on the device accessible, but it's about making the planet more accessible. And to do this, we apply advances in machine learning and artificial intelligence, what I call the Google magic, to meet the needs of underserved communities. Last February, we launched Live Transcribe, an accessibility-first experience, enabling anyone to have a conversation without feedback. Allowing anyone to have a conversation, even if they can't hear. You can think of Live Transcribe as captioning for the real world. Sound Amplifier and Lookout are also great examples of building accessibility-first experiences. And you can think of this overall approach as a practical, useful, and potentially transformative application of augmented reality. So why is this important? Why do we care? Many of us, in fact, including myself at one point in time, believed that disability was something that only affected a small set of the population. Even in the strictest sense, that set is massive. It's 1 billion people, or 15% of the world's population. But let's start to think about disability a little more holistically. So if we include people who don't self-identify as having a disability, this number, 1 billion, it doubles, it grows. If we think of friends, family, and loved ones of folks who have disabilities, well, then that number grows again. And thinking of this even more expansively, if we think about disability to include people with temporary conditions like a broken arm or a broken leg, or situational ones like driving and texting, don't do it, then our circle expands to include nearly the entire planet. So it's really everyone's work to make not just our products, but the planet more accessible. And when we do so, we're affirming that accessibility is a human right. So apart from doing the right thing, I'm going to talk to you a little bit today about why there are some very positive karmic consequences when we design for accessibility first. So much so, a term was coined for it, and that term is the curb cut effect. So you see, back in the day, there were no curb cuts, just as at one point in time, there were no closed captions. So that meant that people who use wheelchairs effectively encountered a wall every time they came to a curb. So in 1945, there was a guy in Kalamazoo, Michigan, named Jack Fisher, who was disabled, and he advocated and fought for the installation of the country's first curb cut, and they caught on globally. Sidewalks, and more importantly, cities, became independently navigable for the very first time. And this had positive consequences literally for everyone, for parents with kids in strollers, for people toting luggage, for workers with dollies or hand trucks. And now today, we can't even imagine a world without them because we're much safer and it's much easier to get around. And this is what was dubbed the curb cut effect. Another realization of the curb cut effect is closed captions. Personally, I love captions. They're great for the World Series or the World Cup at a loud bar. They let me listen in silence when I'm on the train or at the library or I don't want to bother my coworkers. As awesome as they are for me, they're game-changing for the 466 million people on the planet who have hearing loss. So about a year ago, we prototyped and built an accessibility-first application called Live Transcribe, and we launched it in February. I'm going to switch over and do a little demo of Live Transcribe.
Whoa.
Demo? Yep, great. So this is nothing special. This is a basic Android smartphone. As you can tell, I'm just speaking naturally and quickly, and it's picking everything up in real time. It works in over 70 languages, and it's a great tool or a great bridge to carry around with you in your pocket if you need to transcribe a conversation. It's amazing. It also captures very subtle nuances. So I can say something such as, I bought a New Jersey in New Jersey, and it doesn't work for the demo, but I usually say it, and I usually say, I bought a New Jersey in New Jersey. Well, it doesn't like it. It usually gets context, but the demo gods are not forgiving today. It also has a great feature which we call Typeback. So if you prefer not to speak, or in case you can't speak, you can type a response back to the person speaking right here in the interface. So it's really more of a two-way conversation tool than it is strictly captions. Awesome. My demo didn't work. Back to the slides, please. So now that we literally have captions in the real world, what's the next frontier for captions? So I'm super glad you asked. Let's turn to the growth of online video and build empathy for people who are missing out on this explosion of content. So every minute, 400 hours of video are being uploaded to YouTube. So we saw that this was a problem, and in 2009, we added automated captions to all the content on YouTube, which was an awesome first start. But what about personal videos, social media, podcasts? You know, the stuff that we love to use each and every day. They're typically uncaptioned, meaning for the deaf and hard of hearing, it's effectively a silent movie. So led by the Creative Lab in New York, who is here today, we started exploring a simple question. Could we automatically caption any media playing across your phone? So together with a whole bunch of teams from Mountain View and New York and Tel Aviv and Speech Research and the Creative Lab and Audio Framework at Accessibility, we banded together and we spent a year trying to solve this problem. And so I'm going to let the result, live captions, speak for itself and switch over to the demo. So I'm using Google Photos, and this is nothing special here. It's a video of my cat and my fiance, and a little message that they recorded for me.
Hi, honey. Hope you're having a great time at I.O. We miss you so much. Tico misses you. Hope you're having a great time.
So you can see I can caption anything on the device, and it went away. Let me bring it back.
Hi, honey. Hope you're having a great time at I.O. We miss you so much. Tico misses you. Hope you're having a great time. Hi, honey.
Whoops.
Hope you're having a great time at I.O. We miss you.
So that's live caption, and it works with podcasts, it works with videos that you record, voicemail or instant messaging apps, video, and so forth. And we're super excited. You may have seen that we mentioned it in the keynotes today. What you see there is literally just the tip of the iceberg. So we use recurrent neural networks that we've shrunk down from these monster models that used to run in the cloud, and we run them locally on the device. And that gives us some really cool advantages. So one, it lets the product work offline. So I can be in a totally offline mode. I can be in a plane. It's going to work. Two, audio never goes up to the cloud. So it just sits there locally. And best of all, developers and content providers never need to lift a finger. If there's audio, there are captions. So with live caption, every app, billions of videos, and podcasts from any source are one step closer to being universally accessible on Android. Now, over to Melissa to talk about how we use research to inform our most important product-making decisions.
Okay, thank you, Brian. Hi, everyone. My name is Melissa Barnhart, and I'm a researcher on Android. And today, I'd like to talk to you about the user experience. So when you think about the user experience, I'd like you to think about empathy. Empathy is at the heart of design. Without the understanding of what others see, feel, and experience, design is a pointless task. And to be empathetic technologists, we have to set aside our own assumptions and consider other perspectives. Now, a great way to build empathy is through user research. User research focuses on understanding behaviors and needs through a variety of methodologies like interviews, observations, or survey, just to name a few. Like a compass, user research can help point you and your product in the right direction. And you can utilize user research at any stage in your design and development process. Before you begin building, user research can uncover unmet needs and inspire designs that actually meet those needs. The number one reason for startup failure is lack of market need for a product. But you can minimize this risk by conducting research before development even begins. And when development is underway, user research can help you evaluate different design solutions and ensure that your user experience stays on track. And then when your product is out in the market, you can use research to help measure the impact of your designs and also to show the ROI. So today I'd like to share an example of how we've used user research to improve Live Transcribe, a new Android application that provides real-time transcription for the deaf and hard of hearing. A team of research scientists at Google identified a new opportunity for automatic speech recognition and built the first prototype for Live Transcribe. So we have the technology, but what about the user experience? We had a lot of questions about Live Transcribe that we hope to address through research with deaf and hard of hearing participants. For example, what are their first impressions of Live Transcribe? Also, how would they expect scrolling to work in both landscape and portrait orientations? Should it scroll from top to bottom? Should it kind of fade away? Or should it resemble a physical book? But our most pressing question was about the visual design. What font style, type form, text size, text color, and background color should we default to? We assumed that users would want to see differently colored confidence levels to indicate the accuracy of the transcription, but we didn't know for sure. And good research starts with good research questions like these ones. So to answer our research questions, we took a mixed methods approach. We started with a usability study in a Google lab to evaluate our minimum viable product with people who had moderate to profound hearing loss. But we also wanted to know how people would use Live Transcribe over time. How would it work in different environments, like in the home or in the classroom? And would people's needs change with continued use? So to answer these questions, we partnered with Gallaudet University, the world's premier university for the deaf and hard of hearing. And that collaboration allowed us to collect longitudinal feedback from faculty and students who use live transcribe in everyday life. And after iterating on our designs based on their feedback and adding new functionality, we conducted a second lab-based usability study, again with participants who had moderate to profound hearing loss. Okay, so let's dig into those lab studies a little bit. Our protocol started with questions like, tell me about a time when you used real-time captioning. What did you like about the experience, and what did you dislike about the experience? So background questions helped us understand previous experiences as well as current needs. Then we enabled the prototype, and we handed it to the participant. And for the next 60 minutes, we initiated conversation about a variety of topics and generally observed how the participants interacted with the phone. We also evaluated different text flows and probed for feedback on the visual design. So in our prototype, white italicized text signified unfinalized text, whereas yellow normal text represented finalized text. Did these participants understand that color and type form indicated confidence in the transcription, and was that information even valuable? So it was in this research that we learned that changing the type form and text color actually distracted participants from the conversation. Additionally, our participants self-reported that italics made reading more difficult for them. And these insights were reinforced by previous research in this space, which says that a transcript is easiest to read when it's not layered with these extra signals. We also learned that our original scrolling text flow felt natural. Unlike the other flows that we showed participants, it didn't force them to shift their eyes to another part of the screen. So because of these insights, we removed those colorful confidence levels. We used a normal type form instead of an italic type form, and we proceeded with the scrolling text flow. And this is just the beginning. We'll continue to make improvements as we conduct further research. But what I really hope to show today is the power of empathy. So by putting aside our own assumptions about the visual design and conducting research with our target audience, we changed the product design to be more legible and ultimately accessible. And next up is Lauren, here to talk to us about dexterity.
Thanks, Melissa. Hi, everyone. My name's Lauren, and I'm a software engineer on Central Accessibility. Now, let's talk a little bit about dexterity, the challenges users with dexterity impairments face, and the services on Android to help with these challenges. According to the US Census, more than 50 million people, or more than 19% of the US population, has some form of mobility impairment. More so, in the US, more than 2 million of these people have an impairment that impacts how understandable their speech is. Over 15 million people have limited dexterity in their hands, and nearly 20 million people have difficulty lifting and grasping. The majority of this population is over 65 years old. Those with severe dexterity challenges include those with conditions such as ALS, cerebral palsy, Parkinson's, or spinal cord injuries. Some conditions result in users experiencing involuntary movements such as spasms and tremors. They may also have difficulties with speech and having their speech understood. Many conditions impacting dexterity are progressive. As loss of dexterity happens, fine motor skills may regress. People might have difficulty with picking things up or maintaining a hold on items. Grasping or interacting with a phone can be particularly challenging for people within this population. There are varying levels of severity of dexterity impairments, and we offer various apps and services on Android that can be used to help users based on their own individual needs. We introduced Accessibility Menu last year, designed to make common interactions easier for people with dexterity challenges. Accessibility Menu simplifies common actions such as power off, locking the screen, and accessing notifications in recent apps. When enabled, it can be opened via a button at the bottom of the screen, which helps those with limited reach. Now we're adding new controls for volume and brightness, so the user can continuously adjust volume and brightness without leaving the menu. We've also added an option for large buttons in settings to make the menu buttons larger. So those that may have more limited hand dexterity can use voice access to control their phone via voice. Voice access uses voice commands to perform gestures on elements on the screen without needing to physically touch the phone. Voice access was recently launched in September of last year. You can download it now at g.co/voiceaccess. Voice access places an overlay of numbers over the actionable elements on a screen. Simply speak to your phone with actions such as click 7 or go back to interact with your phone. When voice access is enabled, you can continue using your usual Google Assistant commands, such as setting a timer or checking the weather. A feedback bar is always present at the top of the screen that captures your spoken phrases. You can specifically refer to elements by their number, such as tap 7, or you can refer to the name of the element. So if you wanted to open an app, or if you wanted to open Google Keep, you could say open Keep. We're also happy to announce that we brought support to French, Italian, German, and Spanish. So voice access is great for those with limited hand dexterity and understandable speech, but there's many out there who may not be able to speak clearly. For those Android users, we have switch access. Switch access allows users with limited hand dexterity and limited speech to navigate through their phone using external buttons or switches. I'll show you what a typical switch might look like. So a typical switch could look something like this with 2 large buttons. And a user can interact with the switch with their hands, or if they have more control in other parts of their body, they may use another part of their body such as their feet. In a common 2-switch case, one switch can be likened to a tab that moves the highlight on the screen when pressed, while a second switch can be thought of as an enter that selects the highlighted item when pressed. Switches can be configured to meet user needs, and switch access can be used with as little as 1 switch. Most input devices work with switch access, including just a regular USB keyboard. So text editing is commonly a pain point for switch users, so we recently added text editing menus. These menus add shortcuts for previously time-consuming text editing tasks, such as highlighting and deleting text, undoing or redoing actions, copy, cut, and paste. This allows text editing to be done much more quickly and with use of as little as 1 switch. I'll show a quick demo of this. So in this demo, I'm using switches configured to the volume keys. Assigning switches to the volume keys is a very easy way for developers to test out switch access on their own apps without needing to have an external switch. So using the volume keys, I'm going to go through the elements on the screen until I get to the text field I wish to edit. I can select the text field, and it brings up our text menus. So I want to move a word around. So I will go to Highlight, and then choose the granularity that I wish to highlight. So I'll choose Highlight Previous Word, which highlights this word peaches here. Then I can cut the word with the menu. And then now I want to paste the word somewhere else. So to do this, I first need to move the cursor. So I can go to Previous, and then I'll do Previous Line to move to the beginning of this text field. And then I can paste the word there. But what if I made a mistake? We have undo and redo actions added to these menus. Text editing mistakes can be very costly for switch users, so these actions allow our users to go more quickly back to text editing. And then now I'll go back to the slides. Okay. So switching gears, let's talk a little bit about what's new for vision. To start with, here's a little bit of background on this population. According to the World Health Organization, it's estimated that 253 million people globally live with moderate to severe visual impairment, and people over 50 are most at risk. 36 million of these people are blind. We're here to help people with vision loss be able to access and enjoy not just their phones, but the world around them. Lookout is an Android app that helps make the real world accessible for people who are blind or low vision by helping them complete tasks and routines more independently. We launched Lookout in March of this year. Now I'll show a quick video that speaks a little more to what Lookout does and how it's used by our users.
I'm not much of a morning person. One of my smart speakers wakes me up. Hi everyone.
everybody, welcome to our wonderful kitchen. Today we're going to do a few little things. How to stay healthy. Trick number 1, drink juice.
I definitely need someone's help to pick out matching socks. A lot of times my daughter picks them out for me. Love you too, miss you too.
The goal is to be less disruptive to that routine that they're engaged in. Patrick Clary, product manager on Google Accessibility. For anyone with any type of impairment or a disability, there's a strive for independence. And I think this is actually just human nature.
You're relying, of course, more on other people to drive you around or help you accomplish certain things. It can be frustrating.
With Lookout, we had been talking to many different users with vision impairments, and we knew that there was a need to provide them with more independence with daily routines. If you're using Lookout for the first time, basically you open it up and you can just start pointing it at things and it will start telling you about the space around you.
Coffee maker at 11 o'clock.
Coffee maker at 11 o'clock.
Coffee maker at 11 o'clock.
Would you like some coffee?
It will tell you about objects, and it can also detect things like barcode and currency.
US dollars at 12 o'clock.
I mean, without these apps, it is a problem because it all feels the same, so. These things that happened today, I couldn't have dreamed about. You know, I dreamed for phones to be talking, they are talking now. I dreamed for ability to navigate more independently, we can do that today.
Artificial intelligence is going to play a major role in the lives of people with disabilities. And in the case of Lookout, it's going to be able to provide these users with an understanding of the space around them.
All right. So, as you saw in that video, Lookout is able to detect and recognize a variety of objects, including currency and text, through computer vision and machine learning. Lookout uses several image classifiers that run continuously on the device. This allows Lookout to process video and provide results to users in near real time. Since information is processed on device, Lookout can even work in airplane mode. Results are also scored based on a variety of signals, including user context. Our goal is to provide the most relevant results to users in a timely manner. Lookout contains 3 modes: Explore, Shopping, and Quick Read, that allows users to further contextualize their environment and what type of information they want out of it. Explore is the most widespread mode that can be used for a variety of daily routines, such as cleaning the house, cooking dinner, or visiting a new space for the first time. Shopping includes on-device barcode lookup, as well as currency detection. Quick Read focuses on text and can be used for activities such as going through the mail or reading labels on items in the kitchen. Here's a quote from one of our users. "I used Lookout once in preparation for making spaghetti. It very accurately described each item without me having to maneuver the device or struggle to get the items in focus." Finding the correct ingredients to use when cooking is something that many sighted users hardly think about. This shows how Lookout can be used to really change lives by helping people who are blind or low vision be more independent. You can find Lookout on Google Play at g.co/lookoutapp. It's available in the US, and it was initially launched on Pixel. And we're happy to announce that Lookout is expanding to Samsung S8 through S10 and LG G7 and G8 devices. Support to these new devices is rolling out now. We want to get Lookout in the hands of as many users as possible, so we anticipate releasing Lookout on more devices throughout the year. Now, I'll hand it off to Kelly to talk a little bit more about what else is new in Vision.
Hello, everyone. My name is Kelly Chen. I'm the program manager from Google Pixel team and based in Taiwan. Let's talk about how to make a phone accessible for blind and low vision users. Talkback is an Android screen reader. We provide spoken feedback so that who are blind or have difficulty seeing, they can use their phone without looking at the screen. Talkback can read the on-screen reader loudly and then users to interact with their devices by gestures. Before we jump into the new feature, I want you to think about something. What will you do to find the movie details? Like what time a movie starts at the cinema? You can navigate it easily on your phone, and it's simple for you. Now, imagine that, how difficult this would be if you couldn't see on the screen. Not so easy, right? Today, we are going to give everyone a better user journey in your screen reader to help you you navigate and find your content quickly. People who cannot see well, they need to swipe one element at a time to let the screen reader to read for them. And if you want to find things, they may need to do a lot of gestures. That's why we enhanced the screen search feature. So we provide a user interface to perform the search. And it can be triggered by not only keyboard shortcuts, but also by touch gestures and voice input. That's more, it provides any language supported by Android. And it's always available you. You can use it in Accessibility Suite 7.3 now. Okay, let's have a live demo. Okay, let's say you are curious that Roland just talked about the switch access. So you want to learn more. So let's see how it works in Talkback without search.
Talkback on Chrome.
And just listen how many swipes I'm doing.
Connection is HTTP. One open tab. More options. Products and features. Google logo. Collapse. Open the accessibility. Products and feature. Explore some of Google product. Resources. Accessibility. Accessibility. Get started with it. Android OS. From hearing aid. Android access. Switch access help. Link. Double tap to activate.
See, it takes like 10 or 20 swipes. And you can imagine that if the link at the bottom, so we may need to swipe more than 30 or 40 times. Now, with search feature, it becomes super easy. Let's try it. So to start search, swipe left and down.
Android OS. Type search term. Showing English, US QWERTY keyboard. Screen
Okay.
search. Editing. Type search term. Edit box.
So it will bring you to search page. Then let's type the switch. But you may wonder how people with limited sight, how they do it. But it's the same behavior. You just touch on the keyboard. If you listen, that's what you want later. You just lift your finger up. Then it works. So let's do it.
S, W, I, T. Selected. Switch. CH. 2 matches.
And a list with matches will be showing. And then you can check which one you are looking for. Then double-click it. It will bring you to the details. Let's see the first one, switch access help, is exactly what you want. And then you go it.
Clear in. Switch access help. Link. Chrome. Get started with accessibility scanner.
Okay.
Link. Double
So
tap to activate.
it's that simple. So the purpose, we get the user to the place faster and to make people more productive and efficiency. Okay, let's go back to the slides. Dark theme. This is one of my favorite features. You know why? Because when I'm in bed using my phone in low light conditions, and I believe a lot of you may have this kind of experience, and it makes it easier for you to use your phone, like read and browse the phone easily. And it's even helpful for people who are sensitive to light or they have low vision. So it's a system-wide dark theme, and you can find the options under settings, and you can find on accessibility and the display. It's coming on Android Q, and it also saves your battery life. Now, let's talk about not just vision, but all kinds of disabilities. Let's try if you want to change your volume. So you click on your value button, and there's a right side of the screenshot. You can see there's a control panel. So it will show only for a few seconds. And you imagine that if people with physical impairments or limited sight, they may not get enough time to do it. So that's accessibility timeouts. It's a new feature. We give us a little extra time to interact with their devices. We help people to find a way, and you can change the time under accessibility settings, so that make people to do it more efficient. What app developer would need to do is they to use the Accessibility Manager API to get a recommended timeout and follow the value. It will work. And this is also coming in Android Q. We will have deep dive sections on tomorrow, so you are welcome to join us. So let's hand it over to Brian for the summary. Thank you.
Thank you, Kelly. Thank you, Melissa. Thank you, Lauren. Thank you, Creative Lab. Today, we talked about our mission of making our products and the real world more universally accessible. We dove into the curb cut effect to drive home how important and what the wonderful unintended consequences of building for accessibility can be. I spoke a little bit about Android and how now with our smartphone, you are able to caption both the real world and almost all of the content on the device. No other operating system in the world can make that claim. Melissa did a wonderful job at describing and demonstrating the before and after of how we use her research to inform our decisions and really upend our own biases and make informed decisions based on data. Lauren demonstrated voice access and switch access, that innovative way to use a 2-button keyboard. I think that is so cool that you can text edit with 2 buttons. It's just awesome. Kelly talked about Talkback, Dark Theme, and all of these wonderful new products that we have for Vision. So I'm not going to keep you guys any longer, but I want to let you know about a couple of other talks, including one today that we're going to do on accessible audio on Android at 5 p.m. on stage 7. So if you want to dive in on the audio topic, we'll be talking about audiograms. It's going to be really cool. We'll do a hearing loss simulation. Tomorrow, we're going to have a talk on demystifying accessibility development on Android that's targeted toward developers. And then lastly, we have 2 accessibility-related experiments tent. One, the experiments sandbox, and the other, the accessibility sandbox. So everybody, thank you so much for coming today. Thank you for your interest in accessibility, and we hope you have a blast at I/O.